Hello everyone. Before starting the lesson, try this warm-up. Determine the values of r and theta. R is the distance from here to here. Theta is this angle in here. We have a circle on a nice coordinate plane, x and y. Here are the coordinates of the point that's on the circle, 4, 4. That is actually enough information to figure out r and theta. Pause the video and see if you can figure out those lengths. If you need a hint, use your coordinates of this point to find the distance here and the distance here. X and y direction, you have a 90-degree angle in between the x and the y directions. This might actually help you now. So now that you know x and y, you can calculate r using the Pythagorean theorem. As an exact answer, it's 4 root 2. You can also use 4 and 4 as the opposite and adjacent sides in this right triangle. So the tangent of your angle is 4 over 4, which is 1 in lowest terms. Now you might recall from the previous lesson that we have these special angles. So look at the table of your special angles. For which angle is the tangent equal to 1? Well, the answer is 45 degrees. Now we're going to extend our understanding of the ratios sine, cosine, and tangent, the trig ratios, not just with the special angles, but we're going to extend to any angle between 0 and 360 degrees, a full circle. So we're going to evaluate the primary trig ratios for angles between 0 and 360 degrees. Now, when we're talking about angles from 0 to 360 degrees, this is of course a full circle. And I want you to visualize this and keep this in your mind as we go through this. We have an x-axis, we have a y-axis. I'm going to refer to something called a terminal arm, and that is this line that's in red here. It is the distance from the center of the circle to the edge of the circle. Now I'm indicating this angle here, theta, as the angle between the x-axis and the terminal arm. Notice that my angle starts here and works counterclockwise in an increasing direction. So the angle increases from here in this direction. So if you imagine the terminal arm just laying onto the x-axis ending here, this would be a 0-degree angle. If I move that terminal arm around the circle, now it's here, that's a 90-degree angle. Keep moving though. Now I'm at 180 degrees once I reach here. And now I'm extending, now I'm at 270 degrees, and I keep that terminal arm moving. Now we're back to where we started, that's 360 degrees. So 0 degrees and 360 degrees are both here. The angle increases as you move counterclockwise around the circle. So I'm going to go through the terminal arm in different quadrants. Quadrant 1, if you'll recall, is over here. Quadrant 2 would be here, quadrant 3, and quadrant 4. So here I have an image of my terminal arm in quadrant 1. And for the sake of simplicity, I'm using 1, 1 as the coordinates of that point. So just like in the warm-up, we can imagine this as a right triangle with 1 and 1. And if we use the Pythagorean theorem to find the radius, we would find that it's the square root of 2. Now I can find the sine, the cosine, and the tangent of this angle in here using opposite, adjacent, and hypotenuse. So here are my numbers. Now let's keep going around this circle. The terminal arm ends here. Now we're moving into quadrant 2. So here's the next snapshot. We've moved our terminal arm. So now the angle that it creates is this obtuse angle right here. So if I were to draw in the triangle, I would have a side length of -1 here because I'm going to the left one, up 1. So that's positive. Pythagorean theorem, I would still get the square root of 2 there. And I can use these numbers to find sine, cosine, and tangent of my obtuse angle. Notice the signs, the plus or minus signs. When I have an angle in the first quadrant, sine, cosine, and tangent are all positive. When I have an angle that's obtuse, it now has the terminal arm in the second quadrant. I end up with negative cosine and negative tangent. So the signs are different. Now I could do the same thing, extend down into quadrant 3 and into quadrant 4. I keep rotating that terminal arm around the circle. Notice the signs, plus or minus. The sine of this larger reflex angle is negative for the sine, negative for the cosine, and positive for the tangent. When I extend my terminal arm into quadrant 4, I end up with a negative sine, positive cosine, and negative tangent. So the point I'm trying to make right now is that depending on how big your angle is, it's going to affect the plus or minus sign of your sine, cosine, or tangent. Now, an easy way to remember whether the sine, cosine, or tangent are going to be positive or negative is what we call the cast rule. C-A-S-T, cast, okay? It's an acronym to help you remember in which quadrant you have positive values. So in the first quadrant, all of the values are positive. Sine is positive, cosine is positive, and tangent is positive. Once you get into the second quadrant, only the sine value is positive. In the third quadrant, only the tangent is positive. And in the fourth quadrant, only the cosine is positive. Now remember, the angles start here on the x-axis in the positive direction. That's 0 degrees. When you increase counterclockwise, 90 degrees, 180, 270, back to 360, that helps you figure out what quadrant you're going to be in. So for example, if I wanted to know the sine of 107 degrees, well, 107 is between 90 and 180. It's in the second quadrant. So I would know that the sine of that angle is positive. The cosine and the tangent are both negative. Now, keep this rule in mind. You might want to write this down to help you remember in which quadrant the values are positive. All, sine, tangent, cosine. The cast rule. Okay, so I'm going to walk you through an example of how we would use this. Determine the exact values of the primary trig ratios, that's sine, cosine, and tangent, for a 240-degree angle. Now, we want exact values. If you look on your chart of special angles, you'll notice 240 degrees is not on that list. We only have 0, 30, 45, 60, and 90 degrees. We want to find the values for 240 degrees. So our first step is going to be to figure out which quadrant this angle will be in. So here I've labeled 0, 90, 180, 270. 240 is between 180 and 270. It's somewhere in this quadrant. 1, 2, 3, it's in the third quadrant. If I remember my cast rule, C-A-S-T, in the third quadrant, only the tangent is positive. All your other values will be negative. Now, remember, we're trying to find exact values, and 240 degrees is not on our list of special angles. But take a look at this. In between this terminal arm and the x-axis, there's a 60-degree angle. Now, how did I figure that out? 240 minus 180. That's 60 degrees. So there's 60 degrees in between the terminal arm and the x-axis. Now, why might that be important, you might ask? Well, 60 degrees is one of our special angles. So here's the thing. Remember how I said that in this quadrant only tangent is positive? That means sine is negative. The sine of 240 degrees is negative, but other than that, it's the same as what it is for 60 degrees. So the sine of 240 degrees is equal to the negative sine of 60 degrees. And I know the sine of 60 degrees is root 3 over 2. So 240 degrees and 60 degrees are related. there's 60 degrees between 240 and the x-axis. The only difference is the sign. 60 degrees is in the first quadrant, so sine of 60 is positive. 240 degrees is in the third quadrant, so the sine of that angle is going to be negative. But the absolute value is the same. So if I want to find the cosine of 240 degrees, well, cosine is in this quadrant, so it's negative. Other than that, it's the same as the cosine of 60 degrees. So it's negative 1 over 2. Now the tangent of 240 degrees is positive because it's in this quadrant where tangent is positive. And other than that, it's the same as tangent of 60 degrees. So the tangent of 240 is the same as the tangent of 60 degrees, root 3. So, to recap, to find the ratios, sine, cos, or tan, for any angle, figure out what quadrant it's in, then determine the angle in between the terminal arm and the x-axis. Once you know that angle, your values for sine, cosine, and tangent are the same as what it is for that angle, except the sign might be different. But you use the cast rule to figure out what the plus or minus sign is. So now we're going to do the same question except with a different angle. Now it's a 330 degree angle. I'd like you to try this question the same way I showed you in the previous example, but do this on your own this time and see what you can come up with. We still want exact values for sine, cos, and tan of 330 degrees. So pause the video and try this on your own. Start by finding where your angles are: 0, 90, 180, 270, back to 360. 330 degrees would be in quadrant 4. There's a 30-degree angle between the terminal arm and the x-axis. I know that because 360 minus 330 is 30. So only the cosine is going to be positive. The sine and the tangent will both be negative in this quadrant. Other than that, the values are the same for sine, cos, and tan of 30 degrees. So sine of 330 is negative 1 over 2, cosine is root 3 over 2, and tan 330 is negative 1 over root 3. We're going to switch gears a little bit here. This time, I want to determine all possible measures of the angle when it's between 0 and 360 degrees. So the angle could be any value between 0 and 360 degrees. All I know is that the sine of the angle is 5 over 13. Now the first thing I notice is that the sine of my angle is a positive value. Sine is positive. Now, if sine is positive, use your cast rule. Which quadrant can it be in? Well, in the first quadrant, they're all positive. In the second quadrant, sine is positive. So if sine is positive, it can be in quadrant 1 or quadrant 2. So I've drawn my terminal arm in quadrant 1 or in quadrant 2. Both are possible. Now to find the angle, I'm going to take the inverse sine of 5 over 13. This is not one of my special angles, so I'm just going to have to use my calculator to find this out. And when you put this into your calculator, it will give you an answer, and I'm rounding it to 23 degrees. Now hold on a second. 23 degrees is over here in quadrant 1. It's between 0 and 90 degrees. But what about this other possibility? The calculator only gives you one answer. So this is where you have to actually use your knowledge of the cast rule and the terminal arm and the distance away from the x-axis to figure out what this other angle would be. Now on this drawing, remember this is going to be symmetrical. So if one of my terminal arm possibilities is 23 degrees away from the x-axis, it's going to be the same on the other side, 23 degrees away from the x-axis. So if it's 180 degrees over here, we're going back 23 degrees. Where do we end up? Well, we do 180 minus 23, we get 157. So the terminal arm is either at 23 degrees or 157 degrees. We actually have two possible answers for our angle here. So I'm going to reiterate what we did. We looked at the sign, positive or negative. What quadrant could the terminal arm be in? Well, it could be in this quadrant or this quadrant, because in both those quadrants, sine is positive. When we put the inverse sine of 5/13 in our calculator, the calculator only gave us the acute angle as the answer. It's up to us to determine what the possible obtuse angle is, 157 degrees. But if you remember that cast rule, and you remember that it's always the distance away from the x-axis, the angle away from that you're using, you can determine whether you're going to add or subtract from 180 to get your terminal arm value here. All that to say, you should have two possible answers for the angle. Now this is basically the same question, just with a different starting value. Here we know the cosine of our angle is negative 0.8192. But other than that, it's the same question. Determine all possible measures of the angle between 0 and 360 degrees. So what I'd like you to do is figure out where your terminal arm could be, in which quadrants, and then figure out what those values of the angle could be. You'll have two possible answers. I'd like you to try this on your own. So pause the video and see how you do. Cosine is negative. So if I use my cast rule, cosine is negative in quadrant 2 or in quadrant 3. The inverse cosine of this value is 35 degrees. Notice I just ignored the negative sign for now because I'm trying to find the angle in between the x-axis and the terminal arm. So it's 35 degrees between the x-axis and the terminal arm in each case. So in the first case, in quadrant 2, it's 180 minus 35 to get to 145 degrees. And in the next case, when the terminal arm is down here in quadrant 3, the angle is 180 plus 35 to get to 215 degrees. So we have two possible answers for our angle, 145 or 215 degrees. This question's a little bit different, but it follows the same theme. We know the tangent of our angle is negative, so we can figure out what quadrant our angle could be in. We're going to determine the value of the other primary trig ratio, so sine and cosine, and then we're going to determine the value of our angle to the nearest degree. Now keep in mind, you might have more than one possible answer for your angle. Use the cast rule to figure it out. Now I went ahead and I figured out the value of theta first. Tan is negative, which means it's going to be in quadrant 2 or quadrant 4. The inverse tan of 15/8 is 62 degrees, which means I have a 62-degree angle between the x-axis and the terminal arm. So whether it's here or here, it's between the x-axis and the terminal arm. So over here, this angle is going to be 62 degrees less than 180, which is 118 degrees. Over here, the angle is 62 degrees less than 360. 298 degrees. So there's two possible answers for the angle. Now let's go back and do the first part, write the other primary trig ratios for theta. I used this tangent ratio that was given as opposite over adjacent, and I used Pythagorean theorem to find the hypotenuse. So I didn't show my work for that, but this is what I got using Pythagorean theorem. Now I can use that to figure out sine and cosine. In the first case, when my angle is 118 degrees, that's over here, the sine is positive, the cosine is going to be negative. So positive sine, negative cosine. Then I can use this little drawing to figure out opposite over hypotenuse for sine, adjacent over hypotenuse for cosine. Same numbers in the other instance, but now my angle's actually over here. So if theta is in this quadrant, the cosine is positive, the sine is going to be negative. So the only difference is the plus or minus signs. So we can find the other trig ratios, sine and cosine, also tangent, for any value. Use your cast rule to figure out what quadrant you are in. And now it's time to practice. So key takeaway, use the cast rule to figure out what quadrant your angle is in. And once you know that, you can figure out plus or minus signs on your sine or cosine or tangent, and you can figure out all the possible values of your angle between 0 and 360 degrees. So if you run into any issues, please reach out for help.